All the presenters, everyone that attends this conference is so friendly, so willing to teach, so willing to learn from you too. So it's not just watching these videos, it's kind of getting that insight afterwards and around at dinner, at drinks, like all the other aspects of the conference besides just like that technical information.
Welcome everyone to probably the first inaugural panel on safety and security. And I can promise you it won't be the last, because we think that this is something that's good for C++ to keep on an ongoing basis. Okay, my name's Michael Wong. I'm a DE at Codeplay/Intel. And for today's session, I've invited a number of people who are well recognized in the community that I know of, have worked for a long time in safety and security. I've invited them because I didn't really want to answer any questions. I want them to do all the work, all the hard work. The only thing I have to do is stay awake and be coherent enough to ask questions.
Yeah, he's not kidding about that. He told us that ahead of time.
Yes. So I think with that, we are still missing one panelist. I hope he comes and joins, but I'm going to spread the time out a little bit and ask each member to introduce themselves and describe a little bit about their work in safety and security, starting with...
Yes, hi everyone, I'm Verena Beckham, and I have a background in software engineering. I was a compiler engineer for a few years. But these days I'm the VP of safety engineering at Codeplay. And so for the last 3 years or so, I've been researching what it takes to develop code for safety critical systems, for example, in automotive. And because Codeplay is all about SYCL, and I very soon realized that we'd have to make a few changes to SYCL to make it usable in safety critical systems. So I'm now also the chair of the SYCL SE working group within Kronos.
Hi, I'm Liber. I'm a computer scientist at Argonne National Lab. I'm also the Library Evolution Working Group Incubator Vice Chair and the Vice Chair for the US delegation to the C++ Committee. So some of my safety stuff is there, and some of it is also back when I worked at a trading firm, because, I mean, if you had a bug and it made a mistake, it could cost a fortune.
Hi, Bjarne Stroustrup. I'm a professor these days at Columbia. Before that, I worked for a bank, writing stuff to support ultra-low latency trading and dealing with security of data coming in and out of the bank. Before that, I actually did some work for Lockheed Martin to do with the rules for how to write software for planes, the kind of planes that fly around and shoot, and should be resilient against getting holes in. And anyway, hard real-time stuff.
Thanks. Hi, my name is Andreas Weis. I'm working for Woven by Toyota, which is an automotive company. I've been working in the automotive industry now for a little over 6 years. So yeah, that was actually my first contact with safety also, so like in the context of road vehicles and in particular functional safety there. I've also been participating in the recently formed safety study group in the ISO C++ committee, and I've been working with the Misra C++ working group alongside with Michael and others for a couple of years now.
Thank you. Okay, so I'm going to start with a few questions, but I want to make sure that you guys can also come up and ask questions just by lining up at the mics. If you didn't have a chance to ask, this man, Bjarne, this morning after his keynote, this is also a chance to continue that discussion, okay? So one of my first questions, just to set the stage of why safety is where it is today, is certainly about, why are we suddenly so concerned with safety, security everywhere, everything all at once these days, okay? maybe some of you guys can give some context as to why we're jumping on this so much these days. I think the one beside you. Yeah.
Because people have been asleep at the wheel for the last 10 years. Some of us has been talking about this and not getting traction for a long, long time. The first talk here as a keynote on the C++ Core Guidelines were about 7 years ago, and some of us had started thinking about this. I was at a talk in Cambridge, England, about 25 years ago, when somebody was standing up giving a talk and says, you better get your act together, because if you don't, the politicians and lawyers will tell you what to do. And they were right. But I don't know why the thing exploded just now, but it was about to explode, and that to some of us was obvious.
What do other people think about why is it just suddenly? Maybe it was always there, as Bjarne is trying to say.
I think certainly from the point of view of the automotive industry, there has been a real revolution happening in the last few years, because all the software in your car used to be very simple and sort of very standard embedded programming, and perhaps even in assembly language. But suddenly they got really interested in advanced driver assistance systems and also autonomous driving, and all of that required AI, and now suddenly they realize that they really need higher level abstractions, and therefore they need to look towards C++ and things like SYCL. And I think that really pushed the safety requirements onto C++.
Thank you. And on other panelists is right, and I want to give him a chance, and I'm going to ask him the specific question that. Go ahead, Gabby.
Gabby, I work for Microsoft and very much interested in safety and security issues as they relate to C++, C and C++ and systems programming in general.
Yeah, thank you. So the question I was asking is, why suddenly, or maybe not so suddenly, that we're so concerned about safety, security in everything, everywhere, all at once?
Well, I think part of it is because I think we're victim of own success. Software has been basically driving every aspect of modern civilization, whether it is watch or phone or traffic control and everything else. And because it is so prevalent, it becomes easy to some degree for anybody to attack. And if you can actually attack that infrastructure, then you can get access to something and have pressure point. And traditionally, we as software developers, we haven't necessarily thought of our peers or people who do the same thing as us as potential enemy. We just like, well, you're a friend. I know you. You know me. We can share the same account, that sort of stuff, right? But those were a long time ago, and the community has been very slow in updating its thinking with respect to change in society and power, economic power, political power, and so forth. These days, you can extract money from a petroleum company by just attacking the infrastructure via software, right?
Okay. All right. Anyone want to add more to it? Go ahead, Nevin. Thank you.
Yeah, I think part of it is we're way more connected now than ever. I mean, we all carry a number of devices which means we're more vulnerable than ever. And people just generally tend to worry. And we've known for years, we've seen software exploits everywhere, not just C++, like everywhere. And yeah, it's finally coming to a head.
Mm-hmm. Would you like to have a lot? Yeah.
So maybe one thing to add is also that we've seen in recent years also like certain innovations in programming language technology in particular, where with regards to like formal guarantees that you can give for certain safety properties, which were like mostly unattainable before that, right? Like the realm of academic projects are now starting to enter the mainstream through some of these new languages like Rust. And that, of course, creates pressure now, right? Like for C++ to also deliver like maybe similar guarantees to what is available there with those new technologies.
Yeah, yeah. So, talking about all the connected devices, they're talking about so much more software, so much more intelligent software, and the encroaching, I guess, perceived threat from other languages like Rust. It's become much more important. So I'm gonna hit you with the question that Herb asked, which is, what are some of the biggest misconceptions about safety and security that you have, that you can think of? Please.
So I can, like, from personal experience, when I joined the automotive industry, that was actually one of the aspects that I was most interested in. Like, what does it mean to like develop in an environment where you really cannot afford to have certain kinds of faults, certain kinds of bugs. And to my surprise, like it's like when it comes to the technical side, like what we are in contact with as software developments is actually not that different, right? There's no magic special sauce, right? Like most of the best practices that we all learned, they apply the same, right? The major difference is in the framework in which the software development happens, right? Like the processes that you have to follow, and the paperwork that is involved in ensuring that you actually follow the best practices. And like that actually, which I found surprising, has probably a bigger impact than like if you look at the actual code, right? The code probably looks the same as what you would find in any like reasonably competent software shop, but it's like the culture that surrounds it that is different from what you might find in a pure software house.
Good. Bjarne.
I'll try and answer the question directly. And seen from sort of an academic point of view and reading the literature, reading the news, I think the major confusion is people think, or at least claim to think, that type safety is security. And well, it obviously isn't, because if you listen to me this morning, you know there's many kinds of ways of breaking a system, violating safety, and also security is a system's property. Always attack the weakest link, and the C++ type system is not the weakest link.
Okay.
I have another suggestion a bit later when other people have had a chance.
Okay.
I'll go. Yeah, so the things I'm talking to people about it is, it's a trade-off. They're looking for some magic bullet to make things, I want everything to be safe, and it's not. And sometimes it's on the side of performance, sometimes it's not. And sometimes it's on the side of being able to reason about your code and making it more correct, and sometimes it's not. And the other thing is, if we have detection mechanisms, like range checking, what do you do when you detect the bug, right? It's great that we can make ways to detect it, but then you have to recover, and that's really hard.
Gabi, I think you had something?
So, from tool provider perspective, I think one of the misconceptions is that you approach safety and security through bottom-up approach. You take every single operation and you try to make them as safe or as secure as possible. And if you follow the principle of Descartes, you compose from little part, you get bigger part, and the whole thing must be safe and secure. I think that is some kind of fiction. in practice, you get something that is slow, probably nobody is using, and then for it is safe because nobody is using it. But when you get to deploy systems in real world, you've got to take a more holistic approach. Even if you have the safest programming language on the planet, I don't know what it means, but I assume you have one of those. It doesn't necessarily mean that the system that you program with it, that you deploy, becomes secure suddenly. Like, even if I have the safest programming language and I build an executable, I still want to turn on address randomization on the executable because, well, the language is safe, but I don't know exactly in which systems it's being deployed. So building a safe and a secure systems requires a lot of parts. A programming language happens to be just one tiny part of it. It's an important part, but tiny part of it. And while I find this subject very, very important, and we in the C++ community, we need to address it in a way that is very satisfactory, I find the hyper-focus on one tiny aspect a bit, I'll call it trolling, because I wouldn't say it shows ignorance. It's more like people who are doing this thing, they know what you're talking about, but the whole conversation looks like trolling, and we don't make the progress that we need to make because the subject is really important.
You've touched on one aspect I really wanted to ask about, because Bjarne pointed this out this morning, and I want to get his explanation as well as people's interpretations. He said that languages by themselves are not safe. And all general purpose languages all have an escape clause. And then he followed up with something that's really intrigued me. He says, C++ is the escape clause in most cases. I really want to hear what can you elaborate more on that? I find that very interesting.
I can try. Many years ago, when I was a young researcher at Bell Labs, my boss said to me, how do you build reliable systems out of unreliable parts? That is the big question. And that is reliability, like security, like performance, is a system property. Mm-hmm. And one of the things you learn is that some parts of the system will break, and you have to deal with it. And from this, you get my emphasis on type systems, on variety of safety problems, and also, as it were, exceptions. Can I think about that question and get it again later?
Yes.
You didn't get a word in its ways.
I think in terms of misconception, one of the misconceptions I think that is still quite prevalent is that safe software is bug-free. And we as engineers, we know that there's no such thing, right? But I think people believe that the safety engineers don't understand that. They live in some kind of fantasy world, and they think that they can remove all the bugs, and if there's still a bug, then, well, there's nothing we can do about it. But in reality, what they deal with is functional safety of the system. So they deal with the higher level safety of the system, and that involves also dealing with the bugs. So if there is something that does go wrong, and it does go wrong eventually, that you have a fallback system, that you can still continue being safe. The system continues being safe even if there is a bug and a component fails.
Thank you, Verena. I really am glad you brought up the idea about correctness and bug-free. So what is the difference between safety and correctness and bug-free?
I mean, it's kind of the degenerate case, right? If you have a perfectly correct program, it's, that's bug-free, that's going to be safe. They just don't exist in the real. They don't exist in the real world, though.
I think.
Right. We don't know what correct is. I mean, when people ask me, what do I mean by safety? It's we don't want our bugs to do that much damage. That's really what we're trying to do.
I think Andreas is for next, and then.
So Verena already led into this. So if you look at the functional safety standards, they have pretty exact definitions of all of this. So they don't speak about bugs, they speak about faults, right? Yes. So like a system is faulty, it's not behaving as expected.
Yeah.
And the crucial assumption that functional safety is built upon is that those faults are not avoidable, right? You cannot have perfect programs, you cannot have perfect hardware, right? Like you might have random hardware faults, which you cannot avoid. But the crucial property that you want to ensure is that if you encounter a fault, you don't harm anyone as a consequence of that fault.
Thank you. You don't harm anyone. Very good.
Yeah, and that it's very close to the notion of dependability. Is the system dependable? Yeah. It comes from perspective that we accept the system will have bugs.
Yeah.
But even in face of bugs and some other mishaps coming, happening, is the system, can we still depend on the system functioning in a way that is acceptable? Yeah. So every time I hear correctness, bug-free and all of that, I think about the Ariane 5 rockets, maybe because I'm French or something, but it was one of these spectacular fireworks that happened when they first launched the Ariane 5 rockets. It was supposed to go up, very up, then turns into gigantic fireworks. And there was a post-mortem analysis that was done by the people, experts in the domain, who knew exactly what these things were supposed to do. When it came out, it was like each part that was involved in the explosion was functioning correctly according to the spec. That's interesting. Yeah, according to the spec. So when you say correct with respect to what?
Yeah.
Right. Then the thing that was not tested, so this testing is integration. When you put all the parts together, were they still working according to expectations? So you can have components that are bug-free,
yeah,
work according to the spec. When they put together, they may not give you what you want. So bug-free doesn't necessarily give you safety.
Yeah.
And you might have a system that is buggy, but is dependable.
Yeah, it's a great story. Thank you. We could have never known that you were French, but
yeah, and as I said, you have to build systems that are safe, are reliable, are performant, even when some of the components don't work right. It's not just to prevent the disasters. You also, in some situations, some systems, want to make sure that the system degrades, but not further than still functioning. I worked in telephony. It was very important that the system didn't go down, even if we have to shed half the load. And talking about the spec and not having correct specs, I'll point out a story that was told to me, and so it's probably true, but if it isn't, apologies, because I've only heard it. There was a spec for ejector seats. If the plane gets too close to the ground, the ejector seat automatically sets off to save the pilot, because if he's that low, it's in trouble. The rumor has it that one of these planes crossed the equator and things happened and the plane got a bit low and the ejector seat fired, shooting him 50 feet into the ground.
And I think Verena had something to add too. Go ahead.
Yeah, and I think there's plenty other things other than just being bug-free, right? I mean, one thing I think was kind of touched on was the safety of the intended functionality, yes. Which means that you can have a perfectly safe or perfectly bug-free system, but if you haven't developed it to the right requirements, then it's still not safe. So if you develop a car and it's perfectly safe, but cannot handle snow, for example, then it's not safe to drive, right, in Canada or whatever.
Yeah.
And the other thing that is really important and something that doesn't get talked about too much, I think, in C++, is the real-time requirements, so the timing requirements. So it's not sufficient to just return the result, the correct result every time, but it also has to be on time every time.
Yeah.
And that's, I think, something that we don't talk a lot about in C++.
So I'm going to keep encouraging people to come up to the microphone and ask questions, but that is actually a great segue because I want to know about this quite a lot for a long time. Should we really be using C++ for safety security, considering it was, as I was told, that it was designed for soft real-time constraints?
I guess I have to answer that. At the time where it was started, I don't think the distinction between hard and soft real-time was significant because the computers were so small and so slow that you had to run as fast as you could to meet the deadline. And I think that when it comes to real-time stuff, you need a language that can deal with hardware and deal with abstraction. And that was what C++ was designed for. And I still think that C++'s success is because I was really lucky of getting the right criteria for a huge range of applications that I happened to not know at the time. So that's why I called it lucky.
Okay. Gabby? And there's a question, are you lined? Okay, so let's go after Gabby. Yeah.
Yeah, I think bad news travel faster than good news, right? Despite all the rap that the C++ community and the C++ language is getting, we don't seem to talk a lot about successes. I think, was it this year or last year when we sent, well, not we, but NASA sent James Webb Telescope over there. And from what the people in charge of the project were saying, a bunch of stuff were written in C++. And it hasn't exploded yet.
Good.
And it's not just the James Webb Telescope, right? We have Mars rover, a bunch of other stuff. We haven't sent repairmen there to go and fix the out-of-band access. That's kind of stuff that we hear about all the time. The point I'm trying to make is that developing a safe and secure system for critical systems, you need to have not just a language, you need to have a process in place. If you don't follow the process, it doesn't matter how beautiful and how theoretically correct your language or safe your language is, you still need to test, you still need to follow through process and specifications.
Yeah. Anyone else before we go? Yeah, go ahead.
I'll just quote Knuth. I have only proved the algorithm correct. I haven't tested it.
Oh, yeah. That's gentleman over there, go ahead.
Yeah, hi. So I wonder if you can talk a little bit about education, certification, accreditation. I think like the ISO organization in other fields has some role in those aspects. And
Absolutely.
Like the ISO committee for C++ is doing the standardization, but like puts the burden on certifications and processes on other organizations such as Misra, etc. And I wonder if maybe the committee can put its... Yeah.
Right. So you're referring to the fact that other functional safety standards all have fairly big burdens of certification, like ISO 26262 and things like that, right?
Yeah.
Okay, so that's a good question about what do you think needs to be added for C++ in terms of certification, education, that could make it approach that kind of level? Yeah, go ahead.
So the committee does have a study group, SG20, that thinks about how education and how to teach people. Mm-hmm. A lot of it is, just teaching modern constructs.
Yeah.
I mean, people, even RAII, people still aren't, people here are embracing it, but, getting the entire community, it's hard. Mm-hmm. Mm-hmm. And we got to get people more modern, because that's how you write better software and safer software.
And I'm going to add one more thing also too, is that a big thing about those standards is also tools qualifications. So I want somebody to talk about that. Go ahead.
Yeah, that's actually what I wanted to mention here. So if you're working in a regulated industry like automotive, this is one of the things that you actually need to care about, right? So that the language that you use, it needs to have a specification, right? It needs to be clear what the language is supposed to do and how the code gets translated into behavior. And you need to make sure that the tools that you use, like the compilers, for example, that they follow this specification. And there is like certification processes in place for how to do this. Another question that I think I heard from this question is, do we also need certification for the programmers that use these tools? Like if you want to become a functional safety expert for road vehicles, you can actually go to an organization like the TÜV, and you can get certified as an expert in functional safety according to ISO 26262, for example. We don't have certificates like that where we would say, like if you want to work as a C++ developer on a critical software project, you need to get certified as a C++ programmer, right? So to prove that you have understood the best practices. And yeah, I don't know how to feel about that. I don't know if that is something that, if it would be better if you, because in other engineering disciplines, right, you need these kinds of certification before you can participate in certain projects. Yeah. So maybe that would be a way to improve it. I don't know.
I don't know very much about certification, so I'm not going to say much about it. But I did write a paper, I think, for either CACM or computer about 10 years ago, conjecturing that we needed to certify either the practitioners or the tools or something like that, and I didn't know how. I still don't know how. I do have opinions about education and some experience in it, having taught freshmen, having taught last year undergrads, early graduate students. And I guess that comes back to the original answer, a myth that I entirely dislike. This is this myth of the C++ language that is very, very popular when people are attacking C++. And I choose the word attack correctly because that's what it is. Anyway, the first rule of the game is don't write C++. And don't teach C++. Arrays and pointers do not belong in chapter 2 of a beginner's or advanced C++ book. I've tried to put my work where my mouth is. So there is a book, you saw the picture this morning, with Swan Song for freshmen that doesn't get to pointers and arrays till chapter 17. I'm revising it because it's still a very good approach to teaching C++. And I would think that if you wanted to certify C++, that you would have to understand how to build and use abstractions, and then also understand and use and avoid using pointers and arrays where they are not appropriate. Both things are necessary. You can't just give up simple hardware access, which basically pointers and arrays are. And if you want to see what I think C++ is today, there's the other book, The Tour of C++, that you can read in a weekend and get a high-level view. One reason I haven't been able to make suggestions about certification is I couldn't see an organization I would trust to certify certifiers.
I'm going to switch to the audience. Go ahead over here.
Hi, I have a very practical question, I guess. Imagine that you're limited to C, right? So that nobody's feelings get hurt. And like, you need to write OpenCL or SQLite or some of the other foundational libraries that we all rely on and that have to be both very, very fast. And, you know, it will be unfortunate. There'll be heartbleeds and stuff with their bugs. How do you do that?
So I think the question is, if you are using a C-based language, like OpenCL or SQL.
Sorry, no.
Is that?
No, libraries. It's not open.
It's about
encryption.
libraries. Okay.
Encryption libraries, the ones that sends data over the internet. Mm-hmm. OpenSSL. Yeah, sorry about that.
Yeah, thank you.
OpenSSL or SQLite. If you write something like that, and you have to write it in C, how do you do it safely?
All right. So, Gabi, please.
So I'm going to give an answer that probably is not what you expected, but it is one that comes from real world. A few years back, almost a decade now, Microsoft rewrote part of its C runtime system. So the C part. The actual implementation, like printf, that kind of stuff, was written in C++. And the interface was provided as Sexton C. So if you're concerned about reliability of the software, but you still need to provide something for C people to use, I don't think you have to give up C++. You can write the implementation in C++ and provide the interface in C. Doing that, you take advantage of the basic checks, good checks that C++ provides. So I'm not making this up. They use CT, you see CRT is written in C++.
Yes. Yeah. Good point.
So since it was a practical question, I'm going to give a very practical answer. If you want to do something like this, you got to make sure that you have your requirements properly laid out so that you know what the thing is supposed to do. You got to have a proper architecture to make sure that you break down the problem properly into parts that are manageable. And then you need to test the living hell out of it. And in terms of practical things, what you have to do, this is basically what you need.
Yes.
And then you need a process that ensures that you follow that.
So first, what these guys said. Secondly, if you can't touch the code written in old style, encapsulate it, put a clean interface in that's designed to make simple things simple and make more complicated things not unnecessarily complicated. By making simple things simple, you minimize the number of user errors. And also, once you've done that, you can fit it into your system, and then over the years, you can improve the implementation. I did an experiment with my students, an exercise 2 weeks ago, so this is new. And I had them write a simple loop with C-style loop, range for each, and accumulate. They were really, really shocked because accumulate and for each and the range for beat the traditional C-style loop by about 30%, and they were using a variety of compilers and a variety of hardware. If you get a decent interface, you can optimize it.
Okay.
I mean, during his keynote, you saw part of what to do. I mean, the file interface is a C interface. And you can put things on the front end of that to make it easier and less error prone and safer. Mm-hmm. And you don't have, in practical experience, you don't have to do that all at once either. Find the common parts, put RAI in front of that, and then as time goes on, improve that.
Okay.
But I think it is true. I don't know if that was where the question was going, but that there is a type of low-level code where you are forced to use these very low-level C++ or even C constructs. And that means that you have to break these rules, don't use pointers, and all these Misra rules of, avoid doing bit fields and whatnot. But the point is that it's okay if you do it carefully, because all of the safety standards and even Misra, they're very flexible. So as long as you justify every time where you break the rule, it is fine to break the rule.
Thank you. I'm going to just go over. The gentleman's been waiting for a while. Go ahead, please.
Thank you. My question is, so we talk on the conference about new C++ 20, 23, etc. standards, but de facto, when we talk about functional safety, Misra adopted C++ 11 pretty recently. I think AutoSAR is C++ 14.
17.
Already 17, okay.
No, sorry. Yeah, you're right.
14. Was it?
Yeah, you're right, 14, yeah.
Right. Is there any intention to work closer with Misra or to speed up adoption of new C++ features for functional safety?
Very good question. How do we bridge the fact that some of the functional safety requirement standards goes kind of behind C++ releases? There's a lot of knowledge here.
I don't think it's possible.
Okay.
I think if you're writing functionally safe code or a code in a safety critical system, you are necessarily going to lag behind the cutting edge, because for the cutting edge, we as a community just haven't worked out all the pitfalls yet. And because we haven't worked out exactly the right rules on how to develop code safely, we couldn't write the guidelines, and we couldn't write code that we can be confident is safe.
I mean, Misra has been to numerous WG21 meetings, and we've talked with them extensively. But it's hard because, we're kind of teaching them, modern C++, especially the newer features in the language. And, we're the experts at that, and they're the experts at safety and security. And we have to, get education on both sides. And again, that's one of the many difficult problems we have to solve.
Yeah, I mean, as I said earlier, there will be uses of pointers and arrays and bit fields and that kind of stuff. I just don't think it belongs up front for all cases and for the start of things. Build some nice interfaces and you can do really interesting things behind them. One of the problems is when those low-level facilities that are necessary bleeds into the major codes. So instead of having a few thousand lines written by experts in a domain, you have some new student or new developer use the same techniques in a 10,000 or 100,000 line program. We have to separate what we require in different parts of the system, which is part of the profile ideas. We need styles that has guarantees. We need to call stuff that doesn't provide the guarantees except through humans. And we need even profiles that takes all the protections off for the ultimate performance of specific cases, usually things that are isolated from the world and therefore doesn't need the security and safety that we are talking about now.
So Verena gave a perfect answer, I think. So I want to bring up one aspect here. So where this gets problematic is if you have in a newer standard, in a newer language standard, certain language features that would be beneficial for safety. And the only reason you don't have access to those is because you don't have the guidelines for that language version, right? That is the problematic case that we want to avoid. That has been a problem in the past with, that was part of the reason why the AutoSAR coding guidelines came to be in the first place, right? Because Misra just was lagging behind.
Very much.
People thought that we really could benefit from these features in C++ 11 and 14. And I think like the Misra working group is very aware of that and is trying to ensure that we don't lag behind as far as we did back then.
Before you pass the microphone, now you work in Misra almost every week, sometimes twice a week on call.
Yes.
What is their current status? Can you tell us?
Oh yeah, so there's actually good news. There is a new Misra C++ standard coming up. So we actually finished work on it. It's now in the final stages of publication. So you should be able to buy it very soon.
And what is it based on? What version of C++?
This is now based on C++ 17. Although if you look through the rules, you probably won't find a whole lot of rules that are really like specific to 17. But we updated a lot of the old rules just to like be more in the spirit of like modern C++. So yeah, you won't find a lot of the rules that we left untouched. We really gave it a proper workover.
Thank you.
I think you said something very important, that you weren't focusing on C++ 17. Too many people see C++ as a layer cake, and they want to know, is it 11, is it 14, is it 17? If you're asking such questions up front, you're probably wrong. You're looking at the problem. You should look at the problem. You should look at what's the best tools there are. You should look about your tool chain, what is well supported, and then you use the new features where they fit into this general view of what you're doing. And I find that, especially when I go on the web, people go on and on about the latest feature and the latest standard and such. I had a book come out last year which uses only a little bit of C++ 23, and I had heard people saying, "Well, is it worth reading because we've got 23 now?" It's a view of the whole language, and I think we should, when we are looking at it, look at the problem, look at the tool chain, look at the whole language, not trying to fit into one of the versions of it. At least that was what I got out of what you said, and I wanted to emphasize it.
Good point. And it's Gabby, actually, over there. Yeah.
Yeah, I just wanted to add an aspect to it. So when we're faced with building a safety critical system, there are a lot of things that we need to choose. We don't always pick the latest one. Usually we'll take the LTS one. So the LTS is not the newest, fancy stuff that everybody is talking about. So in that perspective, I think of C++ 17 as LTS when I'm looking at the available tool sets. C++ 20, there are some compilers support it, but not all of them support it. And we're still, as you point out, we're still debugging the pitfalls and building wisdom. So I consider 17 in this specific case as a good LTS to use.
This is very good. I mean, I think a lot of people always hop on, use the latest, the very latest, and what you guys are telling me, even something haven't really thought about, is that you want the one with the healthiest ecosystem, that has the widest support, the biggest audience. Thank you. I think this gentleman was actually here first before.
So just wanted to add, I hope people understand. I'm not telling them don't use C++ 20.
Understood. Yeah. Yeah. One more quote. Yeah.
Always experiment with the latest, but deploy with what's stable in your environment for your application.
Thank you. Go ahead, please.
So I was wondering, probably more and more AI-generated code is getting deployed each day.
Yeah.
What does that mean for safety and security? And would you rather have AI-generated Rust over AI-generated C++?
Wow. Would we rather have AI generated C++ versus Rust or something else? Okay. I think Gabby can say something about that.
I'm going to jump in the fire. So as I think we pointed out earlier, you can have the safest programming language on the planet. It doesn't necessarily mean that the system that you get out of it, that you build with it, is actually safe and secure. You have to look at the whole thing. When you're talking about AI, we have to understand the technology. we're talking about probabilistic logic, right? It most likely makes sense. Would you like to get onto a plane whose software was AI generated by Rust, which is most likely correct, but hasn't been tested? How would you feel when a pilot announced, ladies and gentlemen, welcome aboard on this new plane, and the software, automated software, has been AI generated and mostly correct?
And by the way, that was an AI speaking, not a live pilot. There's very little data about that. I heard some reports from a friend of mine in Spain that said that the students were using AI, and for that reason, the quality of the suggested solutions were declining, because these systems are basically large-scale plagiarizing. And with more students submitting their stuff into GitHubs that was read, you got more and more novice student code into the source.
That's called reinforced learning.
It's not simple.
Yeah, I don't really know how to answer that question, because what is these AIs being trained on? Like, how much good C++ versus how much all of C++ versus how much good Rust versus how much all of. And until you can answer that question, it's hard to answer. Like, right? AIs are good at pattern matching and finding solutions, but they're only finding it in what they're being trained on. So I can't really answer that question.
Just to follow up, is there more good C++ or is there more bad C++ in the accessible code bases?
I think the problem is more that it's not just the code that has to be safe, right? It's the system that has to be safe. And to develop software, not just the code, but to develop a piece of software, and you want to make it safe, you have to follow all the processes. You have to write down your design. You have to design your architecture. You have to, do code review and all of that. So it doesn't really make sense to generate the code using AI, because that will give you no safety, basically.
Yeah. And yet we're looking ahead and seeing more and more about AIs being in cars and autonomous vehicles and other systems. And obviously, people are going to be asking, how do we make it safe? And that's something that a particular ISO group apparently is trying to tackle. But go ahead.
That's a whole other story.
Yeah, and then we are back to the original question, what does safe means? Yeah. If it doesn't have to really function properly, I can make it as safe as you'd like.
Oh, how would you do that?
Your car wouldn't start, so it couldn't crash. The point is, getting the requirements right is a huge problem.
Yes.
And documenting it and articulate it in such a way that developers of the code can understand what they're really supposed to do. Very often you don't actually know what the correct requirement is till you have tested quite extensively.
Yes.
And seen what is really necessary, like, is the plane upside down?
Yes. Yes. In autonomous vehicle, that's called the 1,000,000-mile problem. But now it's become the 10-million-mile problem.
Okay.
Gentlemen.
Let's just be sure. We are not saying this is not important. We are very, very keen on getting things safer for the right definition of safety.
Yeah. Okay, gentlemen, thank you for waiting for all this time.
Thank you. My question is, should we expect a built-in network library in new standard C++? Because I mostly use third-party libraries, and this is a question about security and safe. I think it makes sense.
Okay. Questions about built-in network library that is also safe and secure. Go ahead, please.
I guess I'll have to take this question. We've been trying for a while. We've been trying to do a networking library in 2012, but a lot of the question does come down to, what do we mean by safe and secure? Like, I worked in trading, And, we had point-to-point connections with the exchanges. So an attack vector, we didn't care about encryption at all because that was not an attack vector we cared about.
Yeah.
A car, that's sitting on the road may very well care about, encryption and making sure people can't crack into it. Mm-hmm. But it gets back to how do we, not just having a networking library, but what does it mean to have a secure one? And because for different fields, that means different things.
Yes.
Yeah, I was in that industry too, and Azure works really nice for even ultra low latency stuff. Yeah. And that's technical specification. It's been available. It's been used at a large scale in many industries for about 15 years. And the committee has not been able to agree on making a standard or even to agree on what safety means in this context. But there's somebody who won't have the current thing because it doesn't have built-in safety features. On the other hand, there are people building, safe systems, like it looks after your money, with what we have available.
I'm going to add one more question on that, which has been begging to be asked. What is the difference between safety and security? Is there a difference? People tend to talk about it sometimes in one breath, and are they right? They're the same thing? Are they different things?
Oh God, it depends on your definition of safety and security. When people talk about safety, they very often talk about type safety and memory safety and things like that. That is one important but relatively small part of a system. When I talk about security, I basically want to protect against break-in and stealing and corrupting and things like that. And for that, we look at hardware, we look at software, we look at communication channels, we look at humans operating the systems, of the physical location in which the system is, protection against the electricity going down, and the whole works. And so that's my view of security and safety. Mm-hmm. And one of the things that creates the total confusion is people usually don't define what they mean.
Yeah.
If you saw my keynote this morning, there was a definition of what I meant by type and resource safety. Mm-hmm. And there was some examples about how to break security. Mm-hmm. I have seen cases where security was broken because an operator had a drug problem, and he had a free choice between getting his kneecap removed and doing something nasty to a system. This kind of stuff works if you are trying to break in, trying to break security.
Right.
You start with physical security.
Yeah, yeah. Someone else? Yeah.
Yeah, I mean, security it's people deliberately trying to exploit weaknesses in your system. Yeah. And it really is a whole system thing. And that's, so it's not, orthogonal to safety. They go hand in hand, but it's much more rigorous, and that's it.
Verena?
I think safety is much more on the level of, security is much more on the level of functional safety. So it's a system thing. Mm. And in that way, they are quite similar, but one of them analyzes what could accidentally go wrong through faults in the system, and the other one analyzes how people could attack the system. Mm-hmm. The confusion comes because of the language safety, or what you would call type and resource safety features, because they help both of these. So the language safety features actually help harden the system against attack from certain very, very small subset of attacks. Mm. And they also help the functional safety people make, help the functional safety of the system because they remove bugs. So that's where the confusion comes in.
Okay. Some hands over there.
I agree with everything you said. Going to add the tool set perspective, since this is still C++ conference. So if you attend Bjarne's talk this morning, he explained now he can write safer C++. After you've done everything that he said, when you're concerned about the security of the system that you're going to deploy. So it's a whole thing, like human factors and everything, and the environment where it's going to be executed. There are things like stack pointers. They are not something that you have in your program, source level program, right? We talk about vtable. They are things that we know exist, but they are not things that we manipulate directly in this source code. Yet we know that we have security attacks that go and they just observe how the program is working. Oh, you have a vtable over there. Let me call the right set of functions, and then I'll replace your vtable to the one that I like and do what I want. So it's about exploiting a weakness. So in terms of compiler working, when you compile your code, you've got to tell the compiler, please translate this program for security purposes. That means the compiler inserts a bunch of stuff that you as a C++ programmer have no ability to express directly in the source code. In that aspect, you have a concrete distinction between what it means to program safely and what it means to compile for security.
Good point.
I may have emphasized attacks too much in the discussion of security. What I really think is security is the system functioning correctly under strain, under problems, under component failure and things like that. And there may be more what you're calling functional safety. So take what I said, not meaning just attacks by hostile agents, but also the system having to keep functioning under difficult circumstances.
Okay.
Yeah, and sometimes we get proposals that, like, there was a proposal to add jitting to C++.
Yeah.
Which, from a safety, from a security point of view, is like,
it's
terrifying.
It's a nightmare. Yeah.
But like, I work in high performance computing. It would be great if we could generate a lot of this templates on the fly.
Yeah.
But yeah, it's a balance and it's a trade-off.
Yeah. Gentlemen here have been waiting, so I'm going to ask over here. Yeah, go ahead.
Hi. There seems to be a lot of talk on memory and resource safety and how to use certain classes like shared pointers and things like that, and patterns for how to guard against those things. But I feel like thread safety does not get a lot of love. What are your thoughts on that? And do you have any advice other than to just do a good job?
Thank you. This is one of my personal favorite topics, and I hope that somebody
Michael answer the question now.
can speak to it. What about thread safety? I'm not supposed to answer anything, so that's my escape clause.
Right. I've been in discussions with people who say they want to get rid of all undefined behavior, and I go, so what about race conditions? And they just punt on that because that's very difficult. We don't know how to do it, right? I've stared at a half page of code for 2 days trying to find the bug.
Yeah.
And so I think there's still some low hanging fruit, but that's a much harder thing to try to deal with.
Next.
The reason I don't talk much about it is I always run out of time. It's not that I don't know it's there. You heard a slight bit of it this morning, this idea of the vector being passed over to another thread and thereby creating a dangling pointer by invalidation. One of the things the core guidelines do is to treat a thread like a container. And if it's a container of pointers, it follows the rules of containers, and you do some protection against that kind of problems. I would also like to look more about how unique pointers work in that context. But for now, I think to a very large extent, we have to rely on tools for detecting potential race conditions. And I just never get around to it. It's not that there's lack of love, it's lack of time.
I think the gentleman beside you have something to say.
So in my opinion, one of the reasons why we don't hear about thread safety that often is that in those domains where it's critical, there's a very simple answer to this, which is just don't use threads, do it single-threaded, right? And for most domains, that's an acceptable answer.
Yes.
Yeah, Michael, we've been talking at this very conference a couple of times about our attempt to bring Misra guidelines for working with parallel and concurrent code. This solves parts of the problem, right? There's also the approach that Rust takes, which forbids shared mutable data, which also solves parts of the problem, right? But it's the underlying issue, I think, still remains with all of these approaches, that it's just very hard to reason about parallel code. You have to keep a lot of stuff in your head, and it's you have to think about constructs that are very hard to reason about.
Right.
It's a really difficult problem. So if you don't have to use it, then just don't use it.
Thank you. I'm going to jump in here for a moment I know what Verena works on, and it's one of the most parallel systems out there. In fact, it's so parallel, it's heterogeneous. So if you're working on a safety critical virtual language, how are you going to deal with this when almost everyone is saying, we don't even have time to consider it when, we're so busy on the sequential aspects of programs?
Yes, and that's a real challenge, because I think the safety critical industries, they've only just got to grip with multi-core right now. Right. So for so very long, they took multi-core processors and just turned all of them apart from one off, because they couldn't actually buy single core processors anymore, but they couldn't work out how to program in multi-core. So they are way behind. So they have not even started thinking about how to program a heterogeneous system. And I think similarly how to program in with multi-threaded. But I think it's coming. It's inevitably going to have to be. Everything will have to be multi-threaded and heterogeneous eventually. So they're just way behind, I think.
Okay, Bjarne.
Yeah, I think we sort of undersold our efforts.
Yeah.
I mean, Mike and me have been meeting about every month, trying to get a set of concurrency rules to be both for Misra and for the core, the C++ core guidelines. And so it's coming. Furthermore, the core guidelines have some rules which basically encourages you to stay at a higher level. If you have a message-based system, you can't really get race conditions. At least you have to work hard to get them. And it's much easier to detect. And so that there are some rules. One of the ways of getting better concurrent code is not to work on the threads and lock level all the time.
Yeah. So to summarize, we are aware that it is a problem. In fact, we're probably aware of it more than most people. And there's efforts going on that's working on it. Okay. Gentlemen over there, I know you've been waiting for a while, please.
So I was wondering, so basically we can make everything safe if we have sufficient resources and processes, but that's expensive. So even though whenever we talked about the languages, the discussion sort of shifted to other aspects of safety and security and processes, I was wondering, the language still has a pretty big role because depending on the choice of the language, the processes might become much cheaper. So I think the question is whether C++ can remain competitive when it comes to the cost of developing safety critical systems.
Verena?
But a lot of the cost of developing safety critical systems comes from all of the tools that you use to make sure that your program is actually safe. And C++ has got this great advantage here because there is a ton of tools. There's all these static analyzers, there's great compilers, there's runtime analyzers, profilers, everything. And if you were going to start using a new language, even if it might be a lot safer, as in language safety, if you don't have all these analysis tools, then your analysis is going to be manual, or you're going to have to write those tools yourself. And that's where a lot more cost gets added. Instead of as compared to if you're using a language that maybe doesn't have as many language features, safety features, but it has all the tool chains and everything.
Thank you. Something that we rarely consider is the whole economics. Please go ahead over there. Yeah, Gabby.
Thank you.
Yeah.
I think very often when we talk about safety or just like a new programming paradigm that's not supported by what we already have, it feels very tempting to go and invent a new language to just bring that new functionality to everybody. And the parts that we often underestimate is the cost. When you have a large community, the cost of developing the tools that support the good practice and safety and all of that is shouldered by the entire community. When you have fragmentation, you have small communities, each having their own favorite language, the costs go higher because you still have to provide like that level, that standard, gold standard, right? But now you have a small base of user community to take in the cost for that. So that's part of what pains me a lot as we have been having these debates in the C++ community for the last 3 to 5 years where we need to experiment. But what is triggering to me is everybody going their own way, having their own little dialect or language, pushing for, at least they're not pushing voluntarily, but the end result is the same, is that we have a fractured community, which makes it much more difficult and much more costly to actually bring into reality these tools that we need.
I seem to recall a certain gentleman was standing up here this morning talking about economics.
So if I may interject before that. So I think I'm actually really impressed by how Rust is delivering safety economically. For one, they managed to hit a really good sweet spot where they have an analysis that is not too expensive, not too sophisticated, but delivers a lot of value with what it provides. And the second thing that they did incredibly well was providing that checker in a form that it's usable by developers, right? I mean, like I mentioned this briefly earlier, we had academic tools before that gave similar kinds of guarantees, but they were almost unusable for like everyday code, right? And Rust, and this, I have the highest respect for this, that they managed to write a tool that is actually usable by everyday developers and that they can get like easily without too much efforts to these guarantees. And that I think is really an example that we should pay close attention to and should strive to emulate if possible.
Thank you.
My view is that when it comes to delivering real software, you need a balance of tools, you need a combination of tools, you need tools that work together, language features that work together, compilers, you name it. And if you look at the big picture, C++ is pretty good at delivering safe, meaning type-safe software.
Thank you. Gentleman over there, next question.
Hi. If I was asked to give an example of a safe language, 2 languages come to mind right off the top of my head. One is the language of mathematics. One is the language of logic. And when you bring those together, you get mathematical logic. There is an entire discipline known as formal methods and formal logic And so my question is, to what extent or what productive role could formal methods play, or maybe is playing, in solving this safety problem?
Thank you for mentioning that. Start with Andreas.
Yeah, so I did a bit of formal methods back in my university days. I've been playing around very recently with a language called Liquid Haskell. It uses a concept that is known as liquid types. So basically what they do is they have like contract-like annotations on the functions. And then you basically, if you want to call the function, you have to deliver a proof why you respect the contracts. And they have some machinery with a constraint solver that helps you with coming up with that proof, right? Deduces some kind of things for you so that it's not quite as tedious to do. But still, like this is a very mathematical way to approaching this. But it turns out that this is really hard. Like I've done a fair share of mathematics, and I struggled a lot with getting this stuff to run. This is really difficult. This is an entirely different kind of like brain muscles that you need compared to programming. So yeah, like if you can get something like this to work, it's great, and it can give you like huge benefits for safety. But when we talk about the economics, you pay a very high price for that. And that I think is the main issue that I see with these approaches.
Okay. Gabi?
I've done some work on formal methods, mathematical logic, not just as an academic, but also in the context of C++. I've collaborated with I guess, the leading expert on the planet, Xavier Leroy, who wrote an entire C compiler in Coq, the proof assistant. The work we did was, for example, we tried to formalize the Itinium ABI. That was the first thing. We're trying to, back late 2000, early 2010s, we were trying to prove that REI, resource acquisition management in C++, the protocol is actually sound, like mathematically sound, proven that way. And the first thing we did was, well, if you're going to poke in memory, first you need to understand that the object layout, where the vtable is and everything else you're accessing, they respect the dynamic semantics of programming language. So that got us the first Popol paper, 2011. And the follow-up paper was to actually formalize REI. So this is the Popol 2012 paper, and the proof was done again in Coq with a student from Xavier. Now he's at Misra, Microsoft Research, working again on formal methods. I agree with you. It's very taxing. I'm a mathematician. I was trained as a mathematician. Still, it is very taxing, and it is not. I love the work, of course, and actually it had a concrete consequences on the standard, which is we actually found bugs in the specification. The thing when you're working with a proof assistant like mathematical logic is you have to write the spec. We were talking about spec earlier, like is it correct? Is it correct with respect to what? So you have to write the spec. And if you're using math, this is an unforgiving language. A slight variation gives you completely different results. So we were able to find bugs in this spec. They were fixed and all of that. But it is not something that we can scale. Like, I don't know, we have 10 millions of C++ programmers. I will not dream of getting 100 of them writing C++ with Coq, because it's very, very hard. So when we are talking about economics, we use math. We have to use math to design a system because it is very hard to argue with logical fact, right? So we have to use a mathematical logic. But we also have to be realistic. We have to deliver a system that needs to run today or tomorrow. So we have to make trade-offs. And use intuitions, experience. Bjarne was saying earlier in the morning that the core guideline rules were derived from experience, not invented out of blue sky research. So you need that combination of mathematical logic, engineering, and intuition.
Christian Nygaard, who invented class hierarchies and object-oriented programming, said if we need PhDs from MIT to write our code, we have failed. Just a comment on what you said there. Also, there's a language that has been used for safety-critical stuff for a long time, ADA. And it has a proof system. I've forgotten what it's called. What is Spark, yes. And this is very hard to use. It's very expensive to use. I mean, you basically first have to train programmers for a considerable time before they can start. And it is used a little bit, but if you want to go in that direction, look at Ada and Spark. They have 20, 30 years of experience in this field.
Yeah, I mean, when I started in this, and I'm not going to say when, like many, many years ago, like there was the promise that formal methods were going to, solve all our woes. We're still waiting. It's as you're saying, it's really, really, hard to reason about.
Go ahead.
And one thing that you hinted at, Gabby, is also like math is not the ultimate answer, right? Even if you have a formal proof, you still need to show that your model is correct, right? Yeah. Like the proof is always carried out on a model. If you specified it wrong, or if your mapping from the actual source code to the model is not correct, then your proof still won't catch that, right?
Thank you.
So you basically had a bunch of mathematicians answer you. I know these two are real mathematicians. I'm sort of a fake one. My master's is math. I don't know if we can go around. You're a physicist, right? That's
my master was also math, but it was. But I was an astrophysicist.
I like math, but I like math, but wasn't didn't go that far formally. Although one of my kids is, and now I have two resources. So.
So your mention of ADA's really brought it to my mind, right? I mean, we've all kind of know ADA. It was mandated for the military, and it didn't really catch on fire with anybody, even the military. So the U.S. government has always made these kind of funny, or for lack of a better word, kind of weird mandates along the way. There was a recent one that just caught my eye. What is the United States government publication, NISTIR, NISTIR 8397 on guidelines on minimum standards for developer verification of software? Can somebody, I just got this come across this morning, and I'd like to know a little bit more about what this is all about.
While I work for the U.S. government, I am not here representing the U.S.
Yeah, so at the beginning of the current administration, there was a presidential executive order to secure cyberspace and all of that. And then the president directed the NIST director and a bunch of other government agencies, directors, to implement the executive order. That's the way the U.S. government works. The agencies implement regulations. So among all the brouhaha about how bad C and C++ was and all of that, I think a few folks at NIST actually realized that, yeah, it might not be what we dreamt of, but it is what we have. So given that this is what we have, how can we make it meet our needs? So they came up with a set of guidelines. They recognize that you need both a combination of both static analysis, code analysis, and runtime instrumentation complemented by processes, testing, and good hygiene. Don't put your password in the code, even if the language is safe. Your password is not safe if it's clear in text. And so these regulations from NIST, they implemented a U.S. executive order. And any company doing business with the U.S. government, or directly or indirectly, is now required to follow those guidelines. And what you get now is you have various efforts in the programming community going on. You have the OpenSSF, Open Security Software Foundation, going and has a bunch of working groups. I participate in some of those, especially those related to compiler construction, memory safety, and they have more to do with build systems, processes, and educations, and so forth. So if you're interested in this topic, I very much encourage you to go to the openssf.org and find one of those groups and get involved in them. And parallel to that effort, my employer, Microsoft, which happens to be a big supplier of software, developed a set of concrete guidelines saying, so here is what NIST wants us to do to conform to their specification. Here is how you can concretely use the tools that you have today to meet those guidelines. Okay, so thank you. You have prescription from the U.S. government. Then you have various efforts in the community to meet those guidelines. So the OpenSSF has a working group on best practices. And one of the subgroups of that working group is on developing best practices for hardening C and C++ software through compiler options. And they meet every other Wednesday. For me, it's a meeting at 6 a.m. I'm pretty sure for you. And just recently, we completed the first version of the documentation, and I was pleased to see that compiler vendors are paying attention. So, for example, there is a patch pending at GCC where they're going to have an option called -F hardened, which essentially turn on a bunch of checks that you as a programmer can't do, or some of them you can do, like bound checking arrays and that sort of stuff, to try to respond to meet these requirements from the U.S. government. And Microsoft published guidelines a week ago. And I think there's a blog post that went live today being Monday, and I don't know exactly when you guys watched the video. I encourage every C and C++ developer to read the NIST document and also read these guidelines that are being developed by OpenSSF, Microsoft, and some other companies. Even if you believe that you do not write, or software that you write doesn't need to meet those guidelines, it's still good to read them and get an understanding of what is at play. I implore you.
All right, thank you.
Wait.
Go ahead.
Wait. This is actually a question. So I've always wished for range-checked vectors, strings, and span for starters. And are you telling me that I'll get a standard way of inquiring this so that my dirty trickery that I used to get it becomes unnecessary? And without getting a ton of extra expensive runtime stuff thrown in for good measure.
So I don't know if you'll get an ISO standard way of doing that, but you'll definitely get a practical standard way of doing that. You have a shortcut from the compiler, just say -F hardened. But if you think you're the power user, you can also define a command line macro that all the major C++ implementations, agree on spelling, and they will do the same thing. But from what I know, GCC and I hope soon Clang and also the Microsoft compiler will come with an option where you just turn it on and then you get all these bound checked access and so forth.
As you know, my problem is that I want to drop novices into using range checking and such. I don't want to let them loose with all the problems. And the current set of ways of getting the checking are such that you cannot get novices to install it.
Yeah, I'm sorry, I'm going to have to stop because I am running out of time. In fact, I'm over time, and I would like to. This is actually a great discussion, and have it at a beer later on after this. But I want to close with some questions, just last questions for everyone to have a chance to speak. And by the way, guys, this is not going to be the last of this panel. I think this is such an important topic. We're going to be back here, and I'm hoping some of you guys will be on here. My last question, so that I want everybody to answer. We ranged all over many topics tonight. But one thing I've always kind of bugged me in my mind is, what about the role of a vibrant, properly defined standard for safety? Is that important, or is that just something that gets in the way? I'm going to start with Verena. And then I'm going to go through each of you. Yeah, this is our last words.
It is absolutely essential, right, to have a properly defined standard. Otherwise, how can you be sure that your program is behaving the way it's meant to behave? And how can you be sure that your tool is behaving the way it's meant to behave, and not just the way that you interpret whatever the rules are, and they are interpreting it in a completely different way?
I agree with that. I think the challenge is if we have that, how do we make sure it doesn't fall behind? As we learn more about this, we need to improve it, and it needs to morph. Yeah. And how do we make that happen?
Yeah. But we have so many bugs.
I think the idea of a minimal standard is important. That was the word that was used before. And the same idea for the core C++ guidelines. We have to make sure that the fundamentals are safe, but that we haven't closed off possibilities for improvement. And I've seen standard that simply stops us from doing better than the minimum that is essential.
I think you want a standard here because you want, when you want a safe system, you want to make sure that you're really following like the latest best practices, right? And you don't want that to be like heavily influenced by just what one company is doing, right? You really want like a consensus where the whole field can agree, like this is the right way to do it, right? And even though it's tedious to go through the standardization process, I think that's the only way how you can get that, how you can get this overarching picture, what the best practices are.
Yeah, just the same way that we strive for the same programming construct to mean the same, independent of which compiler you use. That's why we try to have these ISO standard. For safety and security, it's also important that the process, the practices that we go through have the same meaning in terms of outcome. So for that reason, it's very important that we have a standard, but not one that is, we need one that evolves with what we know, technology and new data, not one that is just stop in time and immovable because, well, that's what we knew 10 years ago.
Thank you. Thank you very much, everybody. And thank you very much for staying with us tonight. I really don't have anything more to say. I just want to say, just give a big hand to all these guys who was able to help. Thank you.
Thank you guys for great questions.
Yes, thank you for all the great questions. And keep them coming. And like I said, I know some of you guys are involved in the safety security industry. I just don't know you personally, but I want to. We want to hear you come up and have you sit in these chairs next time. Okay? Thank you very much, and good night.